So, yeah.
It is safe in that sense.
Okay. So that is not really the safety issue. Okay. So I'll tell you another story. I got a lot of stories to tell. Okay. I met Vice Chancellor of Faisalabad University of Faisalabad, Pakistan, and we were just talking about GMO. So the day you were talking about when it was first introduced by Mahiko and Monsanto in India, and you all, maybe some of you remember that big chaos that some fields were burnt and whatnot, some resistance, but thankfully the politicians made the right decision and approved it. So that day, the cotton production was equal between India and Pakistan. Okay? Now we produce more than double the amount of cotton on less acreage than what we were growing back then, and Pakistan is the same still. So now our yield is more than double. Okay? All right. That's one benefit. Before introduction of that Bt cotton, I know firsthand 16 sprays of very poisonous systemic insecticide by plane. That means every single human being was breathing non-stop, right? Because 15 sprays is like every few days spray. And farmers did not harvest anything for 3 years in a row. And just check the numbers, how many committed suicide. Okay? Now we are down to 2 to 3 sprays. Okay? Think about the environmental impact, right? And many other benefits. So insects have the survival instinct just like anyone else. Okay? It is not the Bt gene that is creating mutations in insects. Those mutations are already there. All the other insects are dying except those few that can resist. Okay? That means your jobs are safe. We need to make next generation genes like that, so that the kind that can survive now will be killed then. But even otherwise, the proportion, the fitness of those bugs is so low. I mean, those resistant bugs been around for last 10 plus years, and we haven't seen a single epidemic yet. So their fitness is not at par. They're not increasing in number, so they are under control. So we can just manage by just 2 or 3 sprays at max. And then alternative was 15 plus sprays. That is very, very dangerous. Okay. All right. Any other comments?
How can we silent a gene? By which process?
Doing that. But the easiest and the best used method is by RNAi. Okay? By RNAi, it can be this simple, that you know the sequence of the gene that you want to silence, make complementary, even small segment of that synthetic RNA. Okay? You don't even need to go through this complicated procedure. So once you know the sequence of the gene, you can order a synthetic complementary RNA. All you need is 21 base pairs long. Right? You can, to be on the safe side, you can make 50 base pairs long. At this day and age, you only pay maybe 500 rupees to make something like that. You somehow get that into the system, and next thing you know, your gene is gone. Because this RNA-based approach is self-amplifying. So once it degrades into small pieces, those small pieces go find more RNA molecules and get those degraded as well. So the system amplifies very, very quickly, and then pretty soon the entire gene product is gone. So that, in my opinion, is the best way to silence any gene. In fact, RNAi-based therapies are considered to be one of the most efficient methods of controlling human diseases, because many diseases involve overproduction of specific genes, like cancers, for example. There are specific genes that are turned on in cancerous cells that are not present elsewhere. And those genes can be targeted to be silenced. And then, in fact, the cancer survival is becoming so good. Just in the last 5 years, I would say about 11 or 12 of our faculty members got cancer, 2 of them in third stage, and they're doing fine. Yeah, I mean, even caught at the last stage, even cancers like liver cancers are being cured on a daily basis. So once considered to be the most deadliest diseases, is relatively under check. If you do what doctors tell you to do, have certain tests at certain time, they claim openly that you will not die of cancer and heart disease. Those are the 2 main killers. So RNAi will play a major role in our disease management in the future. Okay? Good time to get into that technology. All right. Other questions? Yes.
Sir, is it experimentally proved that the manipulation of this PH gene does not affect the expression of other genes that may be either involved in any particular protein formation or any other particular expression of the gene?
Okay, that is perhaps the most difficult question to answer because we know extremely little, essentially nothing, how the systems work. Okay? We haven't even gotten to the point that knowing how a single gene works. Okay? If you ask me how many wheat genes, how many genes do you think wheat has? Anyone want to guess? Anyone guess? 5,000? 10,000? 100,000? Okay. Huh? How many? Okay, that's a good number for yeast. Okay? So yeast has close to 6,000 genes, right? But yeast, as you know, is a unicellular organism, and wheat needs to do many more functions. So wheat has anywhere from 75,000 to 150,000 genes. Okay? How many you think we have cloned so far? You can count on your fingers, right? So we got a long ways to go before we even clone all the genes. And then the real work starts. That is, how this gene works with this gene and this gene, and how these 3 genes together interact with these 3 genes working in a different tissue. Yeah, it is extremely a complex process. And even in simpler organisms like C. elegans, that is a big challenge. It will take us a long, long time to understand different interactions because plants are smart just like humans. May not be as smart, but they react to environmental changes very, very quickly. Even simple wind, gene expression changes. So unless or until we start controlling or studying these gene functions in a very, very controlled environment, it would be extremely difficult to understand the interactions. So that means your futures are safe. I hope many of you are thinking about becoming scientists. Right? There's a great future in being a scientist to discover new things. And it will take us a long time to understand that. So no, we don't know for PH gene, how does it interact with other proteins. But if there is a yield penalty of this, we would have known that by now because this gene, when the mutations in this gene been around for a while. Yeah, so we are fairly safe. We can safely say that it does not affect yield much. But we will not release any variety with the pH gene silenced because those plants will not be fertile. So what we are proposing to do is very transient. Just for a few months, we silence that gene only to activate recombination temporarily. Next generation, the plants will be normal with the normal pH gene function.
So, till the date when we are not sure about the expressions or the interactions with other genes, we can commercialize this in the market. So, till then.
Okay, so do you think that every medicine you take, we know the side effects before they get released? Do you think that would be a good idea to do that? Right? So if I am a cancer sufferer, I want this drug yesterday, not even today, not tomorrow, right? So it is all about calculated risks, right? Any product, so all like these new gadgets, do you know what your phones and your computers are doing to your eyes? No, we don't. We will find out in about 50 years how many people lost their eyes because of radiation from computer screens. How many people lost their hearing because of high volumes of your bad earphones. Right? We don't know any of those answers. And but should we ban everything? No, that's not the right answer. So we just take calculated risk. All right. Any other questions?
So at the industry level, can we say that our government and government has to and allow us to do such manipulation? I mean, what about the ethical and social?
Okay, so let's say the ethical issues, right? So a generation before yours, taking a medicine was against ethics and many of the religious institutions. Are you going to propose we do not go to a doctor? Some people still do that, right? There is these cults in the US, Amishes. They do not believe in today's medicine. And then what the youngsters are doing, they run away from home to get treatment. Okay? So our ethical definitions change over time. And we humans take a long time to accept something. Okay? There is nothing natural about the way we live these days. This is not nature. Right? How many of you would give up air conditioning for living in natural air? Probably no one. Right? Okay. So where's the ethics there? We are using everything for our comfort, right? And that's exactly what we are trying to do for foods as well. People want to eat, they want to eat good food, they don't like to feel hungry, right? And then these ethics will change over time, right? Same thing, the big debate, this is nothing, the food debate is nothing. Bigger debate is cloning. Right? Okay, so there are already at least the unconfirmed reports that there are 5 cloned human beings in this world. All right? There's these church groups and religious groups are just furious over that, right? And then the question we all need to ask is it really unethical, right? Or what were the practices we are practicing now? Ethics question about that. So when someone goes and they can't have a child and goes and seeks doctor's help, is that ethical? Right? See, the thing is, we define ethics as a society, and we change our definitions of ethics over time. It's just a matter of time when all this will be accepted. Right? It's a tough question. There isn't a good answer. Yeah. But we can't let technology be stopped. If you read, and I encourage all of you to read Debate on Recombinant DNA in early 70s, you will actually enjoy that. Nobel laureates dead against that. They said they made predictions Like if you allow recombinant DNA now, in 10 years the human race will be wiped out. There will be viruses released into environment, and this and that, like even people like Sharda. Who was Sharda? You all know who Sharda was. So someone like that prominent was dead against approval of recombinant DNA technology. Imagine your life without recombinant DNA technology. Your biotech program would not have existed if there was no recombinant DNA technology. And it was only because Stanford University, with deep pockets and good connections in Congress, owned the patent on recombinant DNA. If it was one of you owning that patent, it would have never approved. Right? If it was one public university owning that patent, would have never approved. But Stanford University had a lot of connections, so they got it approved. And thankfully, that they got it approved. So far, we are still around and doing pretty well, and recombinant DNA has not wiped us out. Okay? So we can learn from those examples. Right?
Is there any other question? Any other questions? I would like to thank Mr. Gill for delivering such an excellent talk. I know you all must have appreciated that and how in the lucid language he has explained you each and everything. So I'm sure he'll be coming. He generally comes 2 or 3 times a year. And I will request Pooja to give the memento to Professor Gill.
All right, I wish you all the best. I'm going to leave a couple of cards here in case any of you have questions about admissions in US or any.